Okay, so let's review some of the goals that we have for this project, and let's start talking about the various samples that we have. So the goals from our proposal. The main goal is to explore the nebulous stream. So the nebulous stream was identified and named in Jose et al. 2008, but they didn't really do very much with it, and they were primarily working with JH and K. And we now know how pretty it looks in IRAC bands and how many sources we can see that are just by eye read in that part of the region. So we're going to focus first on identifying new YSO candidates from that. So we're going to figure out what we're going to describe as members of the nebulous stream, and then we're going to explore the properties of these targets to see if we really do think that they're all candidate young stars. The second main goal is that the 2015 team, combined with the literature, have identified about 300 or 400 YSO candidates in this region, over the whole region, not just the nebulous stream. So we're going to take those 300 or 400 young stars and look at what the new data is telling us about those stars. Can we learn anything more about them? Is the information we have now supporting the idea that they're young stars or disputing the idea that they're young stars? The easiest way to think about that is the distances, right? Because this thing is at 2 kiloparsecs, and if Gaia is telling us that this particular star is at 500 parsecs, well, it's definitely not part of IC417. But we're going to be able to do more than just distances, because remember, we don't have distances for everything in the catalog. So we'll be looking at color and color magnitude diagrams to try to, as well as SEDs, to try to explore that. Then our stretch goal was to look, the first stretch goal was to look at the previously identified clusters in this region, because there were other people that went through and identified clusters in this region based on JHK star counts, largely from 2MASS. And so they just sort of said, okay, there's a cluster of this diameter at this position. And so they didn't do any exhaustive membership, but we can, because we have this massive catalog now that combines the data from all these surveys, we can look at the properties of the stars in these previously identified clusters and see if we can learn anything about, say, their relative age, among other things. If we have time, so I think we can do that really straightforwardly during this week. If we have time, then the next step would be to try to refine the membership of some of these clusters. Then if we still have time and energy, we want to explore the properties of the long wavelength sources. In other words, things with detections in MSX, Herschel Pax, or Akari that we haven't yet caught up in these other goals. We're going to look and see if those should be included as candidate young stars in this region. And then if we still have time, we'll explore the variability properties of the young stars and candidates in this region. We are not going to get to stretch goal number 3 this week. I think that we can do a good chunk of the way. Well, we're going to finish a good chunk of goal 1 this week, and then we're going to make some good start on that. And once we have the skills from that, I think you'll be able to make a good dent in goal 2. I think, sorry for the cat, I think we're going to have be able to do stretch goal 1A during this week, and then I think 1B should be possible once you go home. And then the stretch goal 2, I think, also should be possible once you go home. Okay, so this is just another view of it. So identifying, exploring, and characterizing members of the nebulous stream, deciding if the new information available since 2015 sheds light on whether or not the literature young stars are still, best thought of as YSOs. And then we can start from the long wavelength detections. We can look at the clusters based on position in the sky, and we can look at the variability properties. And there is definitely overlap among these various samples. So I was trying to explain this in terms of Venn diagrams. I'm not sure I did a very good job, but I'm trying. So if we just regard all objects in this region of the sky, then some subset of them are going to be members of IC417. Some are going to be closer, some are going to be farther. Some are maybe at the same distance, but still not part of that complex. In reality, though, all the objects that are detected is not the same as all the objects that are really there, because all of our surveys have finite limits. We're not detecting everything in all bands. So all objects that are detected in this region of sky, there's going to be some fraction of them that are members of IC 417, and there's going to be some fraction of members that are not detected, and we're not going to know how many there are if we don't detect them. So we're going to do the best that we can with the stuff that's been detected. So if we have then all objects in the region of sky, not just all detections, but all objects, and then the members of IC 417 are a subset of that, then you have a subset of things that have detections in 2MASS. And most of the detections in 2MASS are not going to be members, but some of them are. And then things with detections in GLIMPs there's going to be a lot that aren't members, and there are going to be some that are. And then there's going to be things with detections in Gaia that, there are going to be some that are members and some that are not. And there's going to be overlap among these samples. There's a bunch of things, even though the Venn diagrams don't reflect this, there's a bunch of things that are in 2MASS and GLIMPs, but there's also things that are just 2MASS or just GLIMPs. And there are things with 2MASS, GLIMPs, and Gaia. There are things with just 2MASS and Gaia. There are things with just GLIMPs and Gaia. So, there's a lot of overlapping space, and I've just shown 3 catalogs, and that we have more catalogs than that. So even just within the set of likely members, there's going to be subsets of that too. So there's the subset of things that are in the nebula stream, and there's a subset of things that have long wave detections, and there's some subset of things that are listed as YSOs or candidate YSOs in the literature. And there's overlap there too. Some of the literature candidates have long wavelength detections. Some of the literature candidates are in the nebular stream. Some of the nebula stream have long wavelength detections but aren't already listed as young stars. So there's a lot of different samples that overlap in different ways. So we're going to try to focus this week on things in the nebula stream. The next thing that we'll focus on is stuff identified in the literature as YSOs. That's going to include some from the nebula stream, but I think we're going to try to spend time with some of those this week too. We're going to spend some time on things with the long wavelength catalogs. I don't know if we'll get to it this week or not, but it's not a big set, so this I think is quite doable. Things that are in the right place of the sky to be members of the literature clusters, I think we're going to work with that this week. And the set of things that vary is an enormous task, so we're going to wait on that. And there are things that are going to be in all of those categories, and there's going to be a lot of things that are in none of those categories. And exactly what's in these categories is going to change with time as we work. Because, for example, right now we don't have any guesses as what you guys want to do for the definition of what you want to include as the nebula stream. And we may have an initial guess that we decide we want to refine later. So these samples are going to change with time. And so there are going to be many different source list versions that are going to have different contents, different dates, because that may matter if we decide to change the definition of the nebula stream, for example. And there's going to be different formats, right? Because there's already regions and Excel and text and IPAC table. So there's many different versions already. And every year this is a huge challenge. And every year I try to make it easier. And every year I fail to do it and people get confused. There is not a whole lot I can do about this. It's the nature of the beast. We're going to have to work recursively. We're going to make a guess at what the nebula stream boundary should be, and then we may need to refine it. There's going to be multiple versions of these catalogs, as well as different versions depending on what they're used for, like regions files or table files, etc. I have created already some standard versions of the files that I think we're going to need this week to make sure that we're all starting from the same file version. But you're going to need to keep careful notes. If you change the order of things, or you need to spell out for yourself more explicitly what the contents of the file are, do it. Make notes at the top of the file. Keep track of what you're doing to it. Now, there was one year that I had one of the NITARP teachers get really mad at me because I couldn't tell her where on disk she stored the files. I have no idea where you stored the files on your disk. I have no idea if you changed the file name. So it's on you to keep track of where you save them, how you save them, what directories you put them in, what file names you use. but the clean versions that I'm providing are always going to be available on Box. So if you get confused or you make an edit that you didn't mean to, you can always download versions that are fresh from Box Drive.